So if you look at part A here, notice it's a to the power of 4, and then there's a whole bunch of a squared b and 60b squared. Now if you think about it, I could use this nice little substitution to help us make it look like a question that we're used to. Because a to the power of 4 is really a squared squared. And then here we have minus 7a squared b minus 60b squared. So in essence, I'm thinking now let a be equal to a squared, like that, capital A. So a capital A squared minus 7ab minus 60b squared is something that you're more familiar with. And then we can do the same idea. Find two numbers that multiply to negative 60. Those same two numbers add to negative 7. Dun, 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 ding. What do we get? 12 and 5? Negative? Sure. So therefore a minus 12. And don't forget there's a b now at the end, right? A minus 12b. And then capital A plus 5. However, that's not what we started with, right? What did we start with? Yeah, a squared. So I just replaced the capital A with a squared again. So a squared minus 12b, a squared plus 5b. And that's the answer to A. Okay? So once again, I use this capital A to substitute, to try to rearrange this to look like something we're used to doing. Part B. Same idea now. I look at this x to n. That can be written as x to the power n all squared. Why is that helpful? Because look, I have another x to the power n. And this time I'll use my same trick. Let capital A equals to x to the power n. So the equation actually becomes 4a squared minus 28 plus 25. Yeah. And this, of course, looks like something we can manage. I'll say find two numbers this time that add up to, multiply to not 25, but 25 times 4, which is 100. And those same two numbers add to negative 20. Let's think about the possible combinations and figure out which one makes sense. Boom, 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 boom. Dun, 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 dun. 10 and 10, but make them negative. Good. This time then I'm going to use choose method. So I have a minus 10 times a minus 10. But wait, choose method said I need to now divide by the coefficient of x squared, and then need to simplify. And then after simplifying, what else do we need to do? Yeah, bottoms up to a minus 5. Now, because they're both the same, if you wanted to, I forgot the equal signs, you could just rewrite this as 2a minus 5 all squared. Okay. Ooh. Okay. So I'm thinking for part C, I don't like it being a negative in front. I'm going to take that out first. So 6x to the 8m minus 17x to the 4m y to the 4n then becomes plus 10y to the 8n. Okay? Now, I hope you can realize that the x to the 8m is the same thing as x to the 4m all squared minus 17x to the 4m. Do you see why I did that now? Ooh, y to the 4n. That's a little hint. Y to the 4n, yes, all squared. And if you want to make things a little bit nicer, here's where I make my substitutions. I'll let a equals to x to the 4m, and maybe b equals to y to the 4n. And that will help us because now I can make this look a little bit nicer. Yeah, and we're more comfortable with something like this. So, now it's up to you. Find two numbers that multiply to 60. Those same two numbers add to negative 17. 23? 23? Oh, wait a minute. It has to be negative. Oops. Scratch out 20. How about 12 and 5? 12 and 5. Well, close. How about negative 12, negative 5? So I like that combination much better. A minus 12b. A minus 5b. And don't forget to now, yes, divide by the coefficient. We will simplify. And then bottoms up, I should have done that too. 5a minus 6b. And then now just make a substitution at the end. So negative x to the power 4m minus 2y to the power 4n. 5. Oops, I meant 6. My fault. 6 and 5. Whoops, whoops, whoops. 6a minus 5b. So 6a, which is x to the power 4m, minus 5y to the power 4n. Done. Okay? Now, D and E. Ooh, even more nasty things. I'll let you think about D first. You need to probably factor things out. So, let me quickly do the y plus 2 squared. I'll also take out a negative because I don't like the negative in front. And if I do that, look what's left over, 3x squared plus 2x minus 5. Ah, look. Nice, nice, nice now. Find two numbers once again that multiply to negative 15. Same two numbers add to 2. That's my combination. I hope that's the same as yours. X plus 5. X minus 3. Don't forget to divide by 3. Right? The coefficient in front of the x squared term. Then, of course, we will bottoms up and simplify. And there you go. Now, we really don't need that extra set of square brackets here because we're just multiplying these things. So if you want to just take that out and leave it like that, that works too. There's D. And of course, we'll save the best for last. E. Anything we can take out here? I don't see anything we can take out. But we can let A equal to x squared plus 6x, because then that equation actually just becomes 2a squared plus 13a plus 15. Once again, looks like one of the things we've done before. Great. Find two numbers that multiply to 30 that add to positive 13. 10 and 3, yeah. A plus 10. A plus 3, yeah. Divided by the coefficient in front. We get here a plus 5 after simplifying, 2a plus 3 after bottoming up. Don't forget now we need to replace, so we'll replace the a back with x squared plus 6x. Be careful here, you see I put a bracket because it's double of a, so it's double of every single term in a. And if I want to simplify, I'm almost done. X squared plus 6x plus 5. And then here is 2x squared plus 12x plus 3. Nice. And if you left your answer like this, I'd be pretty happy. But if you want me to be happy, do you see what we can do with one of these things in the bracket? I think we can factor this further. Oh yes, find two numbers that multiply to 5 and add to 6. I know. 5 times 1. So therefore that can be factored into x plus 5 times x plus 1. Now let's think about this other one. think about two numbers that multiply to 2 times 3, which is 6. Those same two numbers add to 12. In this case, 3 and 2, nope. 6 and 1, nope. Not possible. So that one actually was done. And so we'll just copy it here. And this is your final answer. Whew, I hope you enjoyed these challenging ones, but once again, they're not too bad once you can make a quick substitution. And they look like one of the previous forms we've done, and I know you're an expert at that now. You're probably tired of me saying, find two numbers that multiply to this, and find two numbers that add to that. But that's part of